Hello and welcome to this video on Rust programming. In this video, we will learn about integer data types in Rust. So I will not assume that you have any programming experience and then I will start from there. I'll start from the very basics. So if you see this project structure, its name is int type. We have a folder src where main.rs is here. We have target where build files are there. We have git ignore and we have cargo.qml and cargo.log. So how this is created is you go here, you see there is the folder int type. So if you say cargo new my project, then it will create a folder my project. Inside my project there will be src and then main.rs. So you can see that content of main.rs, it will be a simple hello world program. Now Cargo is the build tool and package management and dependency management tool of Rust. You can use Cargo for all the basic stuff like building. For example, I can go to int type and here I can say cargo build, which will give me a debug build, and then I can say cargo run, which will run the program. So there is no output because we have nothing here. Now we come to the crux of this video. So the first question is how a computer understands an integer. So the truth is computer does not understand integer. In the RAM, there are electronic circuitry. There is NAND gate or NOR gate or flip-flops. There are electronic circuitry. And there are two states of these circuitry. You can think in terms of switches. So there are two states, on and off, or high voltage or low voltage. So for example, in your house, there'll be switches on your board. So suppose there are two switches. Suppose there is one switch first. Now it can have two states, off or on. Okay. Now if there are two switches, there are four possibilities. We treat off as 0 and on as 1. So the possibility is 2. There are two possibilities. Okay. It can be 0 or 1. But if there are two switches, then there are four possibilities. 0, 0, 0, 1, 1, 0, 1, 1. Okay. So similarly, if there are three switches, there are 8 possibilities. Okay. Now, these are the types of signed integers: I8, I16, I32, I64, and I28. The numbers after I represents the number of bits. You can think bits means switches. 8 bits make a byte. So bit is the smallest unit you can have in computer. One bit can be either 0 or 1. That is, it can have high voltage or low voltage. So I8 means, I means integer, 8 means 8-bit integer. 16 means 16-bit integer. 32 is 32-bit, 64 and 128 are 64 and 128-bit respectively. So how does computer interpret a number? The computer implements 2's complement. Now we will try to understand what is 2's complement. Consider this 8-bit integer. Okay. So if there are 8 switches, so 1, 2, 3 and 3, 6. This is when all bits are 0 or off or low voltage. Okay. Then you have 1. This is 2's complement. Okay. So in 2's complement, this bit, the most significant bit, the leftmost bit, if it is 0, then the number is positive. Otherwise, it will be negative. If this bit is 1, it will be negative. Now, this will continue till all the bits are 1 till this is 0. Now, the value of this in decimal is 0, and in decimal this is 1, and in decimal this is 0. In decimal it is 127. Okay. So how to convert binary to decimal, that I won't cover. That is a basic mathematics, so you should study that on your own. Now, what happens when this value is obtained? So in 2's complement, when what we do is for negative numbers or positive numbers, how do you convert it? Okay. So you flip all the bits here except the sign bit. Don't touch the sign bit. You flip all the bits here. So you get all ones. Okay. And then you add 1 to this. Okay. If you add 1 to this, then what will happen? This will become 0. All right. So the value of this is this would be 128. Okay. Now if we have 1 1 1 1 1 1 1 1 all ones, then this is -1, because if you flip all the bits here, then it will become 0 0 0 0, and then you add 1, you get -1. Now if you want 2, then you will have to have this. Okay, let me make this 0. Oops. This is -1. Now this is -2. How? Because if you flip all the bits, hang on, this should be 0 and this should be 1. If you flip all the bits, then this will become 0 0 0 0 1, and then you add 1, this will become 0 1 0. So apart from sign bit, this is -2. So let me again use this 1 0. So if you continue this, you will see that this is for -3. So basically you will see that it is decreasing. All right. So this is an increasing sequence for positive numbers. Okay. Sorry, this we already had. So we can make this 0. This is 2. And similarly, we have 3. So from 0 to 127, it is increasing. And after that, it is decreasing. So you see this sequence, it is decreasing in number. And ideally, we would like to put it after this. So this is -128. So you can see that if there are 8 bits, then the number of possibilities is 2 to the power 8, because for one switch we have 2 possibilities, for 2 switches we have 4, for 3 we will have 8, for 4 we will have 16. So for 8 switches we will have 256 values. Now if you add 128 with 127, that would be 255, and 1 for 0. There is 256 different numbers. Similarly, for 16-bit, we will have 2 to the power 16. Okay, that is sorry, not 18, 256. That is 65,536 values. So if you want to calculate this, you can calculate this in Python easily. 2 to the power Python 3, 2 to the power 16 would be 65,000. 65,536, and that by 2 would be half of that, 32,768. That is 32,768, and that 2 minus 32,767. That would be the range of I16. This is I16. And similarly, you can compute for I32 and I64 and all of I128. I size depends on your system. For 64-bit systems, it would be 8 bytes, because the size of pointers on 64-bit system is 64 bits, because it has to address 64 bits of memory. So it is 8 bytes on 64-bit system. For most of Rust programming which we are going to do, we are concerned only with 64-bit system. We will not consider 32-bit or 16-bit or 8-bit systems at all. Now we are clear with our 2's complement. We are clear on how the numbers are stored. Now unsigned integers are very simple compared to signed integers. Now unsigned integers have u signifies I, and 8, 16, 32 and 64, 28 have the same meaning. Unsigned means all the numbers are positive. So since 8-bit numbers have 256 values, the range would be 0 to 255. That would be the range. For 16-bit, the range would be 0 to 65,535. So if you add 0 as one number, the range is 1 to 65,536. So number of numbers which can be represented is same. The range is different. Now let's see how we declare signed and unsigned integers in Rust. So for example, we can say let x is equal to 8. So if you do this, then by default it will be i32. If you want an i8, you have to say that I want an i8 number. You can say that on right hand side, or you can on the left hand side you can signify that I want i8. Okay, so either on left hand side or right hand side. On left hand side it is called that type annotation. If you give it like this, it is type annotation. You give the type of the variable while declaring. Now suppose I have a value 12, okay, and it's say it let's make it y. This is type inference, that is type is automatically found. But if you substitute a bigger number for this type, it will become i64. By default, the variables in Rust are immutable, that is you can't change them. But if you want to change the variable, then you have to declare them mutable. Now you see it was i32, but if I put this number, then okay, what is the error here? Okay, so you see this is i32 by default. Okay, so if I make this i64 the next number, okay, so automatically the type of this variable changes to i64. Now this, which is inside gray background, is given by Rust Analyzer. I have not typed it. Okay, for example, if you remove this, it will automatically become i32. So I have not typed this. This is Rust Analyzer output. So maybe we can disable Rust Analyzer to see this. Leave it. Rust Analyzer is very useful in certain situations. Now you see that it will complain that it is not used. That's why you have a yellow color and triple dot. So we will make use of this. The typical way to print a variable or a primitive variable is double brace. So we can say that x is equal to this and y is equal to this, and then in parentheses you supply those arguments. And println is a macro, so it should be ending with exclamation mark. So once we have this, we can see that in action. We can say cargo build. Okay, maybe it is overwritten before being read. Value is assigned but never read. Okay, so this is complaining because we have assigned value 12, but value 12 is never used. Actually, we overwrote with the larger value. So if we remove this, it will not complain. Okay, it will complain because it's a mutable, but we have not changed the value after this. So instead of that, we can what we can do is Control X. So we, after that we can print this. Now it will no longer complain. So all the complaints are gone. We will have a clean build. Yep, we have a clean build. Now we can say cargo run. So it prints x and y's values. So either you can give the type yourself, or you let the compiler figure out the type for integers. So now this is the basic thing. Now one of the things you should take care in your programs is, suppose we have two integers, okay, x colon i8 is equal to 100, okay, and let y colon i8 is equal to 100. But you know that maximum value of an i8 is 127. So if we say z is equal to x plus y, then it will overflow. You see, it will complain. You'll see when you print, actually it will not give you correct output even if it compiles. Okay, we should get 200, right? For this, you will think that we should get 200, but let's see what happens. All right, so we do cargo run. You see, attempt to compute 100 plus 100, which would overflow. All right, so it knows the value of Z has to be less than 128. So sorry, maximum value of Z can be 127. That is less than 128. That's all right. So what you can do is you can typecast this as I16. Okay. Now it will not overflow because we have typecasted I8 values to I16. So I16 can definitely hold 200. So we have got 200 in the output. So you should be careful about overflow of values when you are doing signed arithmetic or unsigned arithmetic, because the value can actually overflow in the sum. So if you're sure that it will not overflow, you can use the same type. And if you think that it can overflow, then you should try to use the bigger type. With this, I will come to the end of this video. In the next video, we will deal with floating point numbers, and we will see how computer understands floating point number. Specifically, we will deal with IEEE specification 754, which governs the implementation of floating point numbers in most programming languages. With this, we come to the end of this video. I hope that you have found this video useful and informative, and I hope that I have covered the basics of numbers and made you understand the basic numbers. So I'll see you in the next video. Thanks a lot for watching. Happy programming.